Hi guys, so today we're going to go a little further into piecewise functions. As you can see here, I've used the same piecewise function I used in the last problem, and I've also inputted those two functions into Desmos. So first note that the second function, log base 5 of x minus 1, I just used the change of base formula, which is just log of x minus 1 over log of 5. So anytime you have a calculator that doesn't calculate anything other than a log base of 10, you can always use the change of base formula, which is just, I'm going to bring down the negative log of whatever you're taking the log of over the log of that original base. And then I drop down the plus 2. So I use the change of base formula to graph it. We're going to start there. And then notice in the first part of the question, it just asks for the domain. So first, I'm just going to note the conditions. I'm only using x to the third power minus 25x, which is in black, for x is less than 5. That means that part of the graph, I'm trying to trace it correctly, but it goes all the way downwards and it continues, there's like a loop all the way up, and I could only fit so much onto the screen, so just kind of note that, but it's just kind of got a curvature going on there. So I'm only using this part of the graph where x is less than 5, open circle because I'm not including it. And then from there, the graph picks up where x is greater than or equal to 5 with the one in red, which would be from here to here. So what is my domain? Well, if I look at negative infinity, meaning because domain is all the x values, if I look where negative infinity is, as this graph is going downwards, it's also going to go outwards towards negative infinity. So the domain to the left of 5, all the numbers for x are being used. Plus, if you notice here, there's nothing you can substitute into x that would make this function undefined. You could substitute a negative number in, 0, positive. So you could do it algebraically or graphically. I'm just showing you both ways. And then from here, where x is greater than or equal to 5, well, these are the values in red. And as this keeps going, it'll keep going towards positive infinity. So that means that all of the x values are being used from here all the way to there. So negative infinity all the way to positive infinity. So my domain are all real numbers. And then it says to describe the intervals in which the graph of g of x, which I've already highlighted in blue and red, of g of x is positive. So if g of x, meaning, remember g of x is another way to say y, where all the y values are positive, that means that it would be above the x-axis. So where in this graph, where it's highlighted, are the values above the x-axis? Well, that would be from here to here, which would be from negative 5 to 0. And mind you, I'm not including, I'm not including negative 5. Only want the values where it's positive. At negative 5, it's actually 0, which is a neutral number, but it's not positive. So that's why I'm putting it in parentheses. I could go up to 5 where x is negative 5, but I can't actually include that actual number because y is 0 there. And it's positive all the way to where x is 0. And where else is the graph of g of x positive, meaning the y values are above the x-axis. So that wouldn't be from here to here because all of them are below. And then it's from here, right where the red picks up. So this would be from 5. And as we know, we keep going, it goes towards infinity. And how do I know it'll never go below the axis? Because I can never take the log of a negative value. So it's never actually going to go below where x is 1 because 1 minus 1 is 0. If you try to take the log of 0, that won't really work out. So from here, I know that it's also positive from 5 to infinity. You can write this as also union if you want to, but I'm just looking that you have the intervals correct. Okay, I hope this helps, guys.